So we've covered polynomials with complex solutions. What I'm going to do here is I've got a couple of questions based on that for you I want you to have a crack at. So what I want you to do is read the questions, pause the video, have a crack at them, and then come back and check your answers with the solutions I'm going to present here. So here you go. So there you go, 3 questions for you. First using the quadratic formula, then solving in general, and then the third one a little bit more tricky because you've got complex coefficients, but hopefully ingenuity should come through. So pause the video and have a ping at those. So the first one, use the quadratic formula to find the 2 complex roots of this one. Quadratic formula, we've done it since National 5, so it should be fairly straightforward. So we know it's negative b plus or minus square root of b squared minus 4ac. So in this case, negative b, so it's going to be 2, plus or minus the square root of b squared, so negative 2 squared, gives me 4. Take away 4ac, so it's going to be take away 4 times 1 times 10. Take away 40, all over 2a, so all over 2. It's then going to give me 2 plus or minus the square root of negative 36, all over 2. Separate it out, I get 2 over 2, which is 1, plus or minus, so root of negative 36, split that into root 36, root negative 1, so square root of 36 is 6, so it's 6i divided by 2, so it's plus or minus 3i. So therefore my 2 solutions are z equals 1 plus 3i, or z equals 1 minus 3i. That right there kind of shows us one of the theorems we talked about, where if one complex number is a solution, its conjugate is as well. So that backs that one up that we talked about. Second one was solve z cubed plus z squared plus 3z minus 5 equals 0. So similarly to when we were looking at these back a few years ago, what we have to do is first find a solution. Now, have a look at real solutions first. Now, this is a z cubed, so there should be 3 solutions, one of them being real. Fortunately for us, that's quite a straightforward one to find. If I take z equal to 1 and substitute it in, what I end up getting is 1 plus 1 plus 3, which is 5, take away 5, which is 0. So I know that z equals 1, that there is a factor. So I know then that this is going to be z minus 1 times some quadratic there. I just have to find the quadratic. Well, let's use synthetic division to do that. We've got 1 there, we've got the coefficients 1, 1, 3 and negative 5. So 1 goes down to 1, multiplies up to give me 1. I've got 2 there, 2 there, I've got 5, 5 and I've got 0. So what that then means is my original polynomial turns into z minus 1 bracket z squared plus 2z plus 5. So now I look for the solutions of z squared plus 2z plus 5. And for that, just jump straight into the quadratic formula. Save yourself the hassle of doing a lot more maths. So again, negative b plus or minus square root of b squared minus 4ac. So I get negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c, so minus 4 times 1 times 5, so minus 20, all over 2a, all over 2. So that then equals negative 2 plus or minus square root of negative 16 over 2. Separate it and simplify. Negative 2 over 2 gives me negative 1. So I get negative 1 plus or minus root of negative 16, so that's root 16 times I. Root 16 is 4. I get 4i divided by 2, so I get 2i. So I get 3 solutions for this one. I get z equals 1, negative 1 plus 2i, and negative 1 minus 2i. So there you go. 3 solutions for that one. The final question I gave you was the roots of the quadratic z squared minus bz minus c are given by z equals negative 2 minus I and z equals 3 plus 2i. I want you to find b and c in the original quadratic. Now there's a key bit of information in this question, and that key bit of information is this. b and c belong to the set of complex numbers. So my coefficients b and c are both complex numbers in this case. So what I have to do is multiply out my two parts here, gather everything together by powers of z, and see what I get. So what I've got is I've got z minus the negative 2 minus I, and I'm going to multiply that by z minus the 3 plus 2i. What I'm going to do is I'm just going to sort these here. I'm going to sort it into real and imaginary parts before I begin. So what I'm going to have is I'm going to have z plus 2 and then plus I in this first bracket, and the second bracket will be z minus 3 take away 2i in the second. If I then multiply them out, what I end up getting is I get z plus 2, z minus 3 there. I've then got minus 2i times z plus 2. I've then got plus I times z minus 3. And I've then got minus 2i squared. So multiply all of this out, then I can look at simplifying it. So this first bit here, z plus 2, z minus 3, I get z squared minus z minus 6. I've then got minus 2i z. I've then got minus 4i. Multiply out this bracket here. I've got plus zi minus 3i. I've then got minus 2i squared. I squared is negative 1. Minus 2 times minus 1. I've then got plus 2. So now I have to gather everything together by powers of z. So I've only got one squared term, so I've got z squared. Great, that's easy enough. Put all the z's next to each other. So I've then got minus z. I've then got minus 2iz here, plus zi. So minus 2zi plus zi gives me minus zi. I've then got minus 6 plus 2. So I've got minus 4, and I've then got minus 4i minus 3i minus 7i. So now what I have to do is group the bits together and put it in the format here. So in z squared take away b, so what I'm going to do is I have z squared, and I'm going to take it a factor and negative z from each of these bits here. So I'm going to have minus bracket 1 plus I times z, and then I'm going to do the same thing here, take the negative out from that, and then I'm going to have minus 4 plus 7i. And what I can then do is equate the terms. So just by looking at it, what I'm then able to say is therefore b is equal to the 1 plus I, and c is equal to 4 plus 7i. So two solutions, both belonging to the set of complex numbers, one for b and one for c. Look out for the formatting of that kind of one, and just make sure you pay attention to that. That right there was the key bit of information we needed. We needed to realise it belonged to the set of complex numbers before we did anything. Otherwise we'd get to this stage here, not think about that, and have a wee bit of a mild panic attack. Think to yourself, where the heck's this imaginary part come from? Oh dear. So bear that in mind, have a look at all this information, take it all in as you're working through. Bear everything in mind.